You're welcome to this edition of EasyMathsTutor. My name is Jyro and I'm your maths tutor. So I want to say thank you to our returning subscribers, and also if you're new coming here for the first time, you're welcome to this session. Today we're talking about fractions. What is a fraction? A fraction is an arrangement of two numbers where you have the numerator and the denominator. It's an arrangement of two numbers where you have the numerator and the denominator. Now, the denominator, which is the lower part of that fraction, is the total amount of divisions you have for that set of numbers, while the numerator stands for the particular amount of those parts of the fraction that we are talking about in question. So, what are fractions used for? Fractions are used to specify how the amount of a part of something that you're using. For instance, maybe you have a certain amount of money, and you don't want to use the whole money at once. Maybe you're taking $100 to the supermarket and you don't want to use the whole money. You just want to spend $50. So, what fraction of $100 are you going to spend in the supermarket? So, we're spending $50 out of the $100. So that makes it 50 over 100. So that's already a fraction. So fractions help you to specify in a kind of diagrammatic number how you spend or how you use or the part of the full amount of whatever you are using. There's so many examples of fractions. Okay? So today we're going to do addition of fractions. So let us add these numbers. 2 over 7 plus 4 over 7. Now, just imagine you have 7 apples, okay? 7 apples on each side. And then somebody is given 2 parts of the apple, and another person is given 4 parts of the same apple. So how many parts in total were each of them given? So this is a very simple fraction problem. So we're going to draw a long line along the denominator. And since the denominators are the same, 7, we're going to just bring 7 down here. And because they're the same, we're not doing anything special. We'll just say 2 plus 4. Alright? 2 plus 4. So our final answer will be 6 over 7. Final answer will be 6 over 7. 2 over 3 plus 4 over 5. 2 over 3 plus 4 over 5. 2 over 3 plus 4 over 5. Now, this is a bit different from this. Now, the total amount of set of objects you're sharing is the same for this problem. But for this other side, it's different, right? Because the denominator here is 5 and the denominator here is 3. So what we'll do to help us add this up is to make them equivalent, or make their denominators equivalent. So what will make 3 and 5 equivalent has to be the LCM of 3 and 5. And since 3 and 5 are prime numbers, we can say 15. 3 times 5 will give us 15. So 15 will be the equivalent denominator that will help us to normalize each of these fractions, right? So I'll write 15 here. And then when I write 15 here, I'm going to make the numerator of each of them equivalent. I'll make the numerator of each of them equivalent. What do I mean by equivalent? I'm making them equal, okay? I'm bringing them up to the same level. I'm bringing 2 over 3 up to the level of 4 over 5. Do you get me? So if I say 2 over 3, what's the equivalent of 2 over 3 in terms of 5? If I multiply 3 by 5, I have 15. I multiply 2 by 5, I have 10. So that'll be 10 over 15 is the equivalent of 2 over 3. Okay? While this already, if I want to make it an equivalent of 15 also to match with this will be what? Times 3, right? 5 times 3 will be what? 15. 4 times 3 will be what? 12. So it will be 12 over 15. Okay? So that's it. So this will be 10, while this will be 12. This will be 10, while this will be 12. Why did I say that? Remember 5, right? I have to multiply by 5 to make this 15. I have to multiply by 3 to make this 15. I have to multiply by 3, multiply by 5, multiply by 5. I have to multiply by 3, or multiply by 3. Okay? So that's how I got 15, 15, I got 10, and I got 12. So our final answer will be 10 plus 12 is 22 over 15. So that's a fraction, but it's a different kind of fraction because the denominator is less than the numerator. That means there's a whole number in this fraction, right? So how do I bring this out? I subtract here by 15, giving me 7, right? Giving me a fraction of 7 over 15 with a whole number. All right? So that's the solution to this particular problem. Another simple problem. Listen carefully, okay? Don't miss me here. The problem is 1 over 2 plus 1 over 3 plus 1 over 4. Now adding 3 different non-equivalent fractions. Adding 3 different non-equivalent fractions. Like I said in the first part, 1 over 2 plus 1 over 3 plus 1 over 4, we're going to look for a common denominator that's going to make all of them equivalent. So since they're already prime numbers, right? Okay, no, just these two are prime numbers. Okay, so 2 times 3 will give me 6. But 4 will not divide into 6 completely. 4 will not divide into 6 completely. So I'm going to add 2. So we'll say 6 times 2 giving me 12. So 12 will divide each of them equally without giving us excessive what? A very large number. So I'll choose 12. Okay? So 12 divided by 2 is what? Okay, first, let's not run to that. This is 12, right? So how will this be different? No, we'll multiply this by 6. Multiply this by 6 to get 12, alright? What do we multiply by 3 to get 12? 4, right? So multiply by 4 to get 12. What do we multiply by this to get 12? 3. Multiply by 3 to get 12. So we'll say 6 plus 4 plus 3. Alright? So that will give us 13 over 12. 13 over 12. So remember, to convert this to a proper fraction, it will be 1 over 12. Okay? So solve that for addition of fractions. Add 1 whole number 1 over 2 plus 3 whole number 1 over 4 plus 2 whole number 1 over, say, 5. Okay? So we're adding up these mixed fractions. They are mixed fractions because they have whole numbers together with their fractions. So first of all, we're going to tackle the whole numbers first. We'll have 1 plus 3 plus 2. That will give us 6. And then, remember, we're going to look for a common denominator. So we have 2, we have 4, and we have 5. But they are not prime numbers. So we're going to work on, these are common. 4 and 2 are similar. Okay? So we'll go to the larger one, which is 4. So we'll say 4 times 5 gives me 20. 4 times 5 gives me 20. You know, we have to tackle the largest of the denominators together with the largest prime number. That's how we get this. Or you look for the LCM of these numbers. Can we quickly just find the LCM of these numbers? We'll say LCM of 2, 4, and 5, right? So 2, 4, 5. 2 is a common factor. So 2 will go into 2 once. 2 will go into 4 2 times. And we'll bring 5 down because it doesn't go. We'll bring another 2. 2 will not go into 1. 2 will go into 2 once. And we'll bring 5 down. 5. 1, 1, 1. So our LCM is 2 times 2 times 5, which is 4 times 5, which is 20. So what factor will I multiply with 2 to give me 20? That will be 10. So I'm multiplying the numerator and the denominator by 10. What factor will I multiply by 4 to give me 20? That is 5. 5 times 5. Okay? What factor will I multiply by 20? By 5, that will give me 20. That is 4. The whole idea of multiplying the numerator and the denominator is to try to achieve equivalency in all these fractions. When they are equivalent, then we can add them up. Okay? So the answer here will be 10 plus 5 plus 4. Okay? So I'm seeing a very lovely answer popping up here, which is 6 whole number, 19 over 20. So friends, I believe I've done justice to this problem known as fractions. Whenever you want to add fractions, just watch this video. For more of our interesting videos, make sure you subscribe to this channel and also make sure you click on the notifications button. If you enjoy what you're watching here, share it with your friends and like and comment. Thank you for watching EasyMathsTutor. This is a channel where we make you to become a maths lover.